is that? Okay. All right. So good afternoon once again. My name is Dawin Sichimba. I'm a fifth year medical student at the Copperbelt University School of Medicine. So want to look at want to have a tutorial with third year students in biostatistics, and this time want to look at measures of central tendency. All right. So now let's try to make a foundation. Let's try to define a few things. By the way, those are the objectives. To compute, you should be at the end of this lesson, you should be able to compute the measures of central tendency, or rather to calculate, then discuss the uses and limitations of these measures of central tendency, then select appropriate measures. Okay. So now, when you look at measures of central tendency, all right, so these measures, they indicate, okay, where measures are in its distribution for, okay. So when you have values, okay, when you have values from particular, let's say from some results, you did maybe a research, or maybe it was a test in a class or something, okay, and then you have all sorts of values. So now, when you talk about these measures of central tendency, they are going to indicate where most values in a distribution, in that distribution, are falling, okay? And they are also referred to as the central location of a distribution, okay? They are also referred to as what? Central location of a distribution. Now, let's try to think of it in this way. Like, it's as if it's a cluster, okay? Like data is clustering around some midpoint. So you have data, okay? You have some values of data, and then all those values are trying to more like cluster around some mid value, some midpoint, okay? So that's why we call this as measures of central tendency, okay? So now, most commonly in statistics, when we talk of measures of certain tendency, we're talking about the mean, median, and the mode. Okay, mean, median, and the mode. So before we go any further, just trying to briefly define this. When you talk of mean, we're basically talking about the average. Okay, what was the average value of the distribution that you had? Then when you talk about the median, you're talking about the midpoint, okay? If you arrange the values that you had, maybe in either increasing order or in decreasing order, okay? Then you select the midpoint, then that is what is called the median. Then when you talk about the mode, you're basically talking about the most appearing value or variable, okay? So that is what is called that's what is called um, the mode, okay? So okay, now let's try to look at this in a bit more details, okay? So remember, we've already looked at by the way, these measures of central tendency, they are kind of falling under analysis, okay? Remember, I'll take you back to the definition of statistics. We said that it is a science that deals with what? There are 5 things that we mentioned. One, there is collection of data, there is organization of data, then there's analysis, okay? There's analysis of data, then there's interpretation, and finally there's presentation. So the previous lesson, we are basically talking about things, how to present the information that you've obtained after doing whatever survey, research, whatever you're doing. Now, measures of central tendency, when you're calculating measures of central tendency, what you're doing basically is like you are analyzing, okay? It's part of analysis, okay? So now, graphs and tables remain useful, okay, for presentation. So they do what? They summarize data using descriptive measures, okay? So now, when you talk about data as well, we can talk of it in terms of a statistic and in terms of a parameter, okay? So a statistic is something is data that is derived from I mean, like a value that is derived from a sample, okay, sample data. Then when you look at a parameter, it is from a population. For example, if you're talking about let's say uh, the number of patients that presented with a certain condition, let's say malaria, okay, then in that case you're talking about parameters. But when you're talking about, let's say for example, like the cases themselves, the number of cases, or maybe let's say for example, like in a class where you look at the results, then that is a statistic. Okay, so parameter, you're dealing with a population, then statistic, you're dealing with a sample data. Okay, so now let's look at this. So a single value typical of entire data set. So this is what we're talking about. We said that a measure of central tendency, it indicates where most values in a distribution will fall or are falling. Okay, and that's why it is also referred to as the central location of a distribution. So it's like all the values, okay, all the values, or rather all the data in the data set is falling somewhere around that single value, which is called the measure of central tendency. Okay, so an average value of a set of values, it is also what is called the measure of central tendency. Okay, now like I mentioned already, we have the most commonly used in statistics, we have the mean. Okay, most of the times we say arithmetic mean. Then we have the median and the mode. All right, now let's look at the mean. So the mean, we are very familiar with the mean. All right, we are quite familiar with the mean. So the mean is describing basically the average of what you have, of the data set that you have, the average. Okay, so how do you calculate it? You add all the data in your data set, you add them. Okay, after adding them, what do you do? You divide by the number of those values that you have. So let's say for example, you have uh, you have you have students in a class. Some got, let's say they got some got 30%, others 40%. Let's say maybe we're talking about three students. To make it simple. So one got 30%, the other one got 60%, the other one got, let's say, 96%. All right. So we say that the average mark of those three is going to be calculated as you add the 30%, you add the 60%, and the 96%. When you add them, then you divide by 3 because there are 3 marks there, isn't it? So that is what is called the arithmetic mean. Okay. Now, so let's look at the formula. How do we calculate that? So let's consider a random variable x, which takes values x1, x2, x3 up to xn. All right. So we denote, okay, we denote the mean of x of these variables, okay, using that sign for population parameter. Remember we talked about it, a population parameter and data sample where we look at a statistic, isn't it? All right. So now this x, there's supposed to be some sort of a dash on top there. Okay. So now, so we use this for population parameter and we use that for a sample for a statistic. Okay. So this is what we have. So how do you calculate? Remember we said that you add all the variables that you have and then you divide by the number of those variables that you have. Okay. So you have x1 plus x2 plus so on up to the last variable and then divide by the total number of the variables. So it is the same calculation basically, even when you're looking at population mean. So sample mean and population mean, the calculation is the same, except the symbol that we use are different. But the formula is just the same, okay? So there's no difference in terms of formula and the calculation itself. What is different is just the symbols that are used to represent that. Okay. So in the first, on this part, we're saying that where n, this n is representing what? Is representing the sample size, okay? Now, in the next part, in this case, so in this case, for sample mean, the n is representing sample size. Then for population mean, the n there is representing population size, all right? So here, the n is representing population size. So this one is sample size, this one is population size. So what the n is representing is dependent on what exactly you're calculating, whether it is sample mean or the population mean, all right? So what are the properties of the arithmetic mean? Some of the properties of the arithmetic mean is that, one, it is unique, okay? There's no other measure of central attendance which is calculated in the similar way as the mean is calculated. Then it is easy to understand. You cannot have so much difficulties to understand how to calculate arithmetic mean. Then it is distorted by extreme values. Let's say, for example, I'm sure there have been times before where, let's say in a class, all right, in a class of, let's say, 100 students, then you find that most of the students, they get below 60%. And for that matter, most of the students have gotten below 50%, meaning that most students have failed the test, right? Then in that case, because it's like all the variables, all the values are below 50%, all right? Then you find that when you calculate the average to see the general performance of students, you're going to find that maybe the average mark is going to be somewhere around 40%, okay? That is going to give an impression that the average performance of students was quite poor. And then in that case, the teacher or the lecturer may decide what to do, may either moderate the results or may give another test and so on and so forth. Or if they want, they can go ahead and use those same results to determine the progress of students in that particular class, okay? And then let's look at a case where majority of the students get below 60%, and then maybe a few of students in that class, they get an extreme value. They get somewhere around, maybe let's say it's one gets 100%, another one gets maybe 96%, another one somewhere around 95, and so on. Maybe just about 3 or 4 students out of a class of 100, they get somewhere around 90-something%, above 95%, and the rest of the students have gotten below 60%. So you find that when you calculate the average mark, okay, it is going to give you somewhere around 50%, 50, 55, and so on. So that will give an impression that majority of the students, they performed quite well. The performance was fair. And yet, it was only a few students that got extreme values, extreme marks. The rest of the students, they got way below average. You see that? So that is another property of arithmetic mean. So you don't use arithmetic mean alone to determine the distribution of variables in a particular data set, okay? So you use the other two measures of central attendance as well. All right, so let's look at the median, okay? So the median is basically what is also called the 50th percentile, okay? 50th percentile. So what does it mean, 50th percentile? You get let's say I'll still refer to results in a class test, okay? Let's say, for example, you have the test is goes up to, let's say, 100%, okay? Then 50th percentile is obviously going to be something like 50%. And then how many students got below that 50th percentile, got below 50, and how many students got above 50, okay? So in this case, we're talking about like this graph that is shown here. I also added this graph, okay? It is showing the height of grade 10 girls, all right? So this side you're showing, it's showing the cumulative frequency. Then this side, it is showing the height, okay? So 50th percentile, so this is 50, all right? So 50th percentile, it is going to be somewhere at 25, Okay. So what is the 50th percentile? What height is the 50th percentile? So when you follow that line and go down there, going to find that it is somewhere around 6 point, 1 point, this is in centimeters. This is going to be something like 164, about 164, 163 centimeters. So 163, 164 centimeters is the 50th percentile. Okay, so it means that about half of the girls were below 164 centimeters, and about the other half were above 164 centimeters. Okay. Now, how do you calculate, other than using a graph like this? How do you calculate the median? Okay. So there are two cases that you can have. Okay. There are two cases that you can have. You can either have a situation where you have an odd number, okay, an odd number of variables, or an even number of variables, okay, in a data set. So how do you deal with each of those? So we've already talked about the mean. This is the mean, okay. We'll talk about the variance later on. But when we have an even number, when you have an even number sorry, this one is for odd, right? I think this should be a mistake. Here, the first part here, this is for an odd number, okay? So if you have an odd number of variables, all right, what you do is that you add a 1 to the number of variables that you have, okay? You add a 1, and then you divide everything by a 2. So let's say, for example, you have let's say 9, okay? You have 9 variables. Then when you add a 1, you're going to get 10. Then divide by 2, it's going to give you a 5, okay? Meaning that after arranging those variables in some ascending order, okay, either ascending order or descending order, all right, then the fifth, okay, the fifth variable, the fifth value is what is going to be called the median, okay. The fifth value is called the median. But in a case where you have an even number, okay, an even number of variables in a data set, in a particular data set, you simply divide by 2, okay, by 2, and then you add that and divide everything by 2, okay. So where this n is, the n is what is an even number. So this one is supposed to be odd, this one is even, okay. So when it is odd, you have to add a 1 to the number of variables that you have, and then divide everything by 2. I wish I was using a board. It would have been much easier to illustrate, okay. So we're saying that median is the middle value of an ordered sample of numerical values, okay. So extreme values do not affect the median as much as the mean, okay. For example, length of stay, how, let's say maybe house prices and so on. So when you compare, the difference between the median and the mean is that median, in as much as extreme variables, extreme values can affect the median, but it does not affect that much as compared to the mean, okay. Then when you talk about the mode, we're talking about the value in the data set that occurs most frequently, okay. The one that occurs most frequently is what is referred to as the mode. Okay, so let's look at that. So properties of the median, it is unique to calculate, it is easy to understand, and not drastically, like I already mentioned, it is not drastically compared to the mean, not drastically affected by extreme values. The mode, it uses least information. You don't need so much information, okay. It is not very useful. It is not a very useful measure of central tendency, all right. It may just indicate like it may just indicate like where much of the data set is falling in what category, okay. Then it is possible to have more than one mode. So let's say, for example, you had 10 students who got let's say 80%, and you also had 10 students who got, let's say, 65%. Okay, and then the other percentages, the other marks, people who are getting those marks were below 10. Okay, so it means that in this case, the most appearing mark is 65 and 80%. All right. Okay, so that's about measures of central tendency. I hope we've gotten something. We're going to end there. I'll stop sharing, and if there are any questions, please feel free to ask the questions.